section 5.3, and now we're going to learn how to actually add the polynomials that we've been talking about together. So what does it actually mean to add polynomials? Well, the idea is this. We're going to combine algebra tiles that represent each polynomial. So we're going to use the sum or addition principle to simplify the results. Let's take a look at our first example here. Notice I've got two polynomials. I've got the 4x minus 3, and that visual representation is here. Can you say thank you? I drew it out for you. And then we have this other polynomial, 4 minus 2x, and that visualization is right here. See? 4 small squares, 2 rods that are shaded. Now, how do we actually show this pictorially or with a picture? If I'm going to actually ask you to add. Well, adding just means using the sum principle to regroup the algebra tiles according to like tiles. You're like, this sounds like what we just did earlier. So, I'm going to ask you now to draw out those 4 white rods, and then I'm going to group together with it the 2 dark rods. Okay. And then I've got the numbers, or the 3 small squares that are shaded. And I'm going to group that with the 4 white squares. Okay. So, after this, I'm going to actually ask you to use the zero pairs principle to simplify. So, I got 2 of those and 2 of those. That combines together to become 0. Goodbye. I got the 3 shaded small squares. I'm going to combine that with 3 white squares, and that says goodbye. And so if you want to simplify your picture, what's remaining now is the following: 2 white rods and 1 white small square. And ultimately what that means now is the following. The answer is this: 2 white, so that's 2x, and then plus 1 small square, that's plus 1. And that represents your remaining tiles. Okay? So, you're thinking, Mr. Lee, this is just like what we did last day by combining like terms. In essence it is. Very good. So, it's not going to be a very difficult lesson if you learned last day's properly. Now, of course, you don't always want to be drawing algebra tiles, so how do we do it algebraically with symbols? Well, once again, to add polynomials, I'm going to ask you to remove the brackets from them, and then, just like last day, add like terms. Now remember, like terms are combined by adding and subtracting the coefficients, those are the numbers in front, of each of the terms. So once again, you can visualize and draw this out using algebra tiles, and I will ask you to do it in class. But right now, if you feel like you don't need that, go right ahead and just do the algebra. Okay? So the first thing is to remove all the brackets. So 3x minus 4 plus 2x plus 6. Next step is to combine the terms that are like together. So 3x and 2x are together. Negative 4 and 6 are together. 3x plus 2x is 5x. Negative 4 plus 6 is just positive 2. That's it. And this is our answer. Okay? I'll do B with you. And now I'll let you try C and D on the back page. Okay? Similarly here, I'm going to ask you to remove the brackets. 6 plus 5. Oops. I just said remove the brackets. 6 plus 5m. And then plus negative 3m. So just remove the brackets. So that's minus 3m plus 4. Combine like terms together. I'll put the m's together. And I'll put the numbers together. With the constants. 5m minus 3m is 2m. 6 plus 4 is 10. Ta-da! Okay, you get this? Turn the page. Your turn. Try C and D yourself. Have fun. Get rid of the brackets. Group like terms. Simplify. Done. Same thing, okay? Remove the brackets. Group like terms. Simplify. 2 minus 6, that's negative 4. Negative 4y plus 4y, that's 0. Once again, don't write it down. Negative 8 minus 8, don't say 0, that's minus 16. So there's your final answer. How do we feel? Feeling good? Feeling good? Feeling good? Alright, now there's one more way of adding polynomials. This is by using the column method. I want to quickly show you that, and you can use either or, it's up to you. But just like in old time elementary math, 3 plus 4, remember doing that? That's 7. Some teachers make you write like this, 3 and 4 in a column added together. It's the same idea, okay? So we can also add using the column form. To do this, we're going to stack the two polynomials. Now the key thing is to make sure all the square terms line up in a column, all the power of 1 or the degree 1 terms line up in a column, and all the constants line up in a column. So what do I mean by that? Let me show you. So let me write down 5y squared minus 6y plus 7. And your goal now is to take the second polynomial and stack it below, but make sure the y squareds line up. So negative 3y squared minus, and make sure the y's line up, and make sure the numbers line up. And the goal here now is to add, so I'm going to put a big plus sign here, and you can draw your bar, just like you did in elementary school. Okay? And now you have to add, but you have to add the terms that are alike. So 7 plus 6, that's 13. Okay? By the way, you don't need to add from left to right or right to left, it doesn't matter. Be careful here, negative 6y plus negative 8y. Negative 6 plus negative 8 is negative 14y. And then 5y squared plus negative 3y squared, that's 5 plus negative 3, or 5 take away 3, that's just 2, so 2y squared. And there's your answer. Okay? Doesn't matter which way you like, I just want you to do it. Okay, one last question here. You can apply this. If I told you that the perimeter was made up of these following polynomials, I'm going to ask you to please now find the perimeter of the triangle. Perimeter, of course, means to add the sides together. So in essence, the perimeter is equal to 2y squared minus 3. I'm going to add to that the side y squared plus y plus 5, and the final side 2y squared plus y plus 5. Okay? So go ahead, you can try this on your own, and then double check your answer with mine at the end. And if you're done, we're done. Get rid of the brackets. Lots of terms here. Collecting like terms could be tricky because there's so many different things. I will collect the y squareds first. Another y squared here. Another y squared there. I'll do the letter y next. So there's a y and a y. And I'll do the numbers last. I'll give them 3, 5, and 5. Whoop, whoop, whoop. Did I get all of them? Yes. Okay. 2y squared plus y squared plus 2y squared. Remember, this is a 1, right? If there's no coefficient in front. So 2 plus 1 plus 2, that's 5. 5y squareds. Y plus y, that's 1y and 1y, that's 2y's. And then negative 3 plus 5 is 2. 2 plus 5 is 7. Voila. That's French, by the way. There you go.